This is about Year 12 vectors. It comes out of 4E collinear. Collinear means that points are in a straight line. If we have 3 points and they all lie on the one line, we call them collinear points. One proof that they are collinear is if this is A and this is B and this is C, if you could prove that AB is parallel to AC, or AB is parallel to BC, then that would be proof of collinear. Therefore, AB equals some constant K times AC would be proof of being collinear, or AB equals some constant MBC. As long as you use the same letter in each of the vectors, what we're saying is that the vector from A to B, if it's parallel to B to C and they both go through the point B, therefore they must be on the same line. That's one proof. The second proof of collinear is to do with if you have position vectors. So position vector OA is A and OB is B and OC is C. Then if we can show that C, which is this vector in here, equals 1 minus m times A plus m times B, then this is my m, which is the constant multiplied by AB. So if we can show this when we have position vectors, then that is also a proof of being collinear. Okay, points A, B and R are collinear with OA equaling A, OB equaling B. So A, B and R are collinear. And I have this O, and that is A, and that is B. Express OR in terms of A and B. And I'm told that R is the point of trisection of AB nearest to B. 3 equal pieces, and that's R there, nearer B. That's going to be my OR. And if it's a trisection, then AR equals 2/3 lots of AB, because it's a trisection and R is closest to B. So OR is going to equal OA plus 2/3 of AB, 2/3 B, plus I've got A minus 2/3 A, so 1/3 A. That's going to be an expression for OR in terms of A and B. So I'm going to break this into 1, 2, 3, 4, 5 parts. 1, 2, 3, 4, 5 parts. And A to R ratio A to B is 3 to 2. I think that there is a misprint here, and that should be R to B. So A to R is 3, and then R to B is 2. So that's where my R is going to be. And A to R in this case is going to be 1, 2, 3/5 lots of A to B. And then you can get an expression for that. And if you look at the next page on the PowerPoint, you'll see that that work's been done there. Exercise 2E, question 2. Let OA equals this, OB equal that, find OR where R is. Okay, so this is my O to A. That's my O to B. And I know that OR is the midpoint of the line, A to B, so that's R and that's going to be midpoint. So O to R is going to equal O to A plus A to R, which is a half A to B, and I could calculate that quite comfortably. And you'll see that on the next page, I've done that. In part B, the point of A to R is 4/3 A to B. So let's think about it. If A to R is 4/3 AB, it's actually longer than AB. So R is going to be over here. Where if I break this into thirds, not equal, but let's say they are, 1/3, 2/3, 3/3, there's 4/3. So O to R is all the way over there. So O to R in this case is going to equal O to A plus 4/3 A to B. And lastly, the point such that A to R is negative 1/3 A to B, which means we're going to be over here, and I've got to break this into thirds. So it's going to be negative 1/3, so it's going in the opposite direction, and you'll see that those calculations are done down here. In question number 3, show that they are collinear. I have used the gradient method, therefore I needed to prove that PQ was K lots of KQR, and that's shown there, and then find the ratio. As you can see, I've been able to do that in the question in that particular spot. So that's it for 2E.